So what we very often do when we apply quantitative analysis, in other words, statistics, is that we evaluate hypotheses. And when I talk about hypotheses, I mean these are some statements about the relationships of certain variables in our data set. Let me give you some examples. So a typical hypothesis in this little data set can be that maybe the study satisfaction is different for man and woman. Um, it can also be maybe the study satisfaction is different on different places. Or maybe on different places, students prefer different means of transportations. Yeah, so you see already in such a small data set, you can already create a lot of different hypotheses. Let's start with a hypothesis that the study satisfaction is different in different places. So the simplest way to do that is basically to calculate the averages for the different places for Paris, Berlin, Madrid, and so on, and then compare these averages with each other. So how do we do that? Again, we use our pivot table. That means we have to click in our table, and Excel automatically recognizes the whole table. Then we click on Insert, Tables, Pivot Table, and I again open in a new worksheet. So again, we have already seen that in another video, I think. Here we have a lot of different areas. Here, for example, the area where we have all our variables of our data set. And here, different areas where we now can create our tables with our variables. Here in this area, our table will be created. So we want to have a table where we have in the first column all the places, and in the second column, the average of study satisfaction. So what we do is we take the variable place, put it into the rows, and then we take study satisfaction and put it into the values. Yeah. So what you see here we have all the places. I will make it a little bit bigger so that's easier to see. Here we have automatically all the places. I will throw it out again, yeah, so that you can see how it is created. So we take the place into the cells. Now you see here we have all the places from our data set, and then we take the study satisfaction into the values. But what you see here, these are not averages, because our scale was from 1 very dissatisfied to 10 very satisfied. You may remember that students only rated values between 2 and 9. So these are obviously the sums. Yeah? So the sums of all the values. But we don't want to have the sum, we want to have the mean. So therefore, you see here is a little triangle. Yeah? If you click on this little triangle, then a menu is opened, and what we need is value field settings. You find the same window if you click here with the context menu, then you also find here value field settings. Yeah, so as always, we have different options to do that in Windows. And here you see we have sum, but we want to have the mean. Here we have German terms Mittelwert. Yeah, so I click on Mittelwert and say OK, and now automatically the mean is calculated here. So if you mark all these values, then at least in Windows with the context menu, you can here change the format of the numbers to number so that we only have 2 places after the comma. Yeah, that's a little bit easier. You don't have to do that if you have other versions, but that's a little bit simpler. Okay, so let's click again somewhere in the table. We have here the averages, and what we see is that the highest study satisfaction is in Prague, yeah, with 6.17. The lowest is in Paris with 4.83. But all in all, the differences are not so big. So let's also create a diagram for which compares these different averages of study satisfaction. So we click on Insert. We first have to click in the tables, then we click on Insert. Here, recommended diagrams, and now we have a diagram here. Yeah, later when you write a research report, for example, you would copy this diagram into your research report. I make it a little bit smaller so that we have enough space here. So here you see again the values, yeah, the averages, and here you see Berlin, London, Madrid, Paris, and Prague. You see here Prague has the highest, followed by Madrid, and London, the lowest we have in Paris, but also in Berlin it's relatively low, the study satisfaction. I would propose to you that you pause the video now for a moment and that you try to do the same thing with means of transportation and study satisfaction, and also with gender and study satisfaction, to see if you have differences between men and women or differences between people who come to university with a car or with a bicycle. So let's have a look at the data set again. We already talked about that we have different types of data in our data set. So for example, study satisfaction is interval scaled with numbers here. So for study satisfaction, we can calculate an average. But if you look at the place or at means of transportation, here we don't have numbers and we cannot calculate any averages. Yes, and we call this type of data nominal scaled. Yes, here with the numbers, we know the 3 is bigger than the 2, but here Prague, Berlin, London, Paris, these are just different cities. Or the different means of transportation are not bigger or smaller, they are just different. So we call these nominal scale data, and the numerical data here we would call interval scale data. So what if you want to evaluate a hypothesis which is about the relationship of nominal scale data? There you could not calculate the average, therefore you could not compare the averages of different groups. For example, if you want to see if the means of transportations are different in different places. Yeah, so because you cannot calculate an average, therefore you need to create a contingency table, or also it's also called a cross table. So I will show you how to do that and how it would look like. So first you have again to click into the table so that Excel automatically recognizes the whole table. Then you click on your file. You click on insert, and here you find the pivot tables again. We create again a new worksheet, and here now we take the means of transportation. Yeah, you remember these different areas, and here is the area where we will create our table. So we take the means of transportation into the columns, and the place we put into the rows. Now you can see, let's make it a little bit bigger, why it's called a cross table. Because in these cells now, the two variables, the means of transportation and the places, will cross each other. And here you will see how many students from Berlin ride a bike. Or here you will see how many students from London come with a car to the university. So therefore we have to take the mean of transportation into the values also now. And now here you already have the number. It's a relatively big table. I will delete the pivot tables here so that you can see the whole table. Yeah. So now it's relatively difficult to compare these numbers, and we have a lot of numbers, so it's not so easy to interpret cross tables. So if you are able to compare the means, that is always much easier. Yeah, you see, there you only have one number per city. Here you have a lot of different numbers per city. But to tell now if more students in Berlin come with a bicycle to the university than in Paris, you could compare here. Paris we have 1, Berlin we have 2, but we have 13 students from Berlin and only 1 from Paris. So we cannot directly compare these numbers. Therefore, very often in cross tables we want to have percentages, because percentages we can compare, and we want to have percentages in a way that all students from Berlin should be 100%, and then we can see exactly how many percent of Berlin students come with a bike to the university, or how many percent of students from Paris come with a bike, and we can compare the percentages directly. So how to do that? We click into the table again. We go on pivot table analysis, and here we have to show again our field list here where we worked with. So now we go again into the values area, and you already know this field, value field settings. You remember here you could change if you have the mean or the count, or also you could show the standard variation or the variance, whatever you need. But we want to change our values now to percentages, and that is here, show values as. Then where we have no calculation, here is again a little triangle, and we open a menu. And as I said, the students in a row, all students from Berlin, should be 100%. So that's why it's percentage of the percentage in the row. So I click on that. I delete my pivot table again. Now you see we have percentages, and all students from Berlin are considered to be 100%, and all students from the other cities also. And now you can compare the numbers directly. And so if you compare the one student from Paris with the two students from Berlin, because we have much more students from Berlin, so one student is 16.67%, the two students from Berlin are just 15.38% of the students from Berlin. So the percentage of students who use a bicycle is higher in Paris than in Berlin. So now you can make some statements. In which city do people prefer cars? Obviously in Prague, 33%. In which cities they prefer bicycles? London, 83%. And in which countries they prefer the public transport? Obviously here Prague with 50%. So again, as a brief repetition, we need to be aware that we have different types of data in our data sets. We have typical interval scale data where we can calculate the averages, and we have also nominal scale data where we could not calculate the averages. Therefore, we need different procedures to evaluate the relationship between two or more than two variables. So if you evaluate, for example, the relationship between place and study satisfaction, then you would always, for study satisfaction, calculate the means and compare the means for different cities. Or if you want to compare study satisfaction and gender, then also you would calculate the averages for males and females and then compare these averages. But if you have, for example, gender and means of transportation, there you could not calculate averages. Therefore, if your hypothesis is that men and women prefer different means of transportation, therefore you would need to create a cross table. Or what we have done, we have said, is there a relationship between the place and the means of transportation? Again, both nominal scaled, so we also have to apply a cross table. And in the cross table, it very often makes sense to have percentages so that it's easier to compare the different categories with each other. And again, I propose that now you also evaluate, for example, the hypothesis, do men and women prefer different places to study? Or do men and women prefer different means of transportation to create cross tables? So to practice that a little bit. Okay, thank you for your attention, and I hope the video was helpful.